Hey everyone, welcome back to The Doctor's In, the podcast where we focus on optimizing the indoor plant environment for crops grown in greenhouses, indoor farms, vertical farms, plant factories, containers, and any other facility where we want to grow plants anytime, anywhere. It's that time of year when no matter where you go, poinsettias seem to adorn every interior space. Grocery stores, places of worship, houses, offices. But did you know that if left up to nature, those beautiful red, white, yellow flowering plants wouldn't bloom until late December, until after Christmas? In order to make these plants bloom in time for Christmas and ready to purchase in November, around Thanksgiving usually, greenhouse growers have learned how to manipulate the development of poinsettias by controlling their short day response through light deprivation and timing. Yes, in today's episode, we are going to be talking about the beauty of short day plants. Okay, so what is a short day plant? Short day plants require an uninterrupted dark period for a specific amount of time, depending on the crop, before flowering is induced. When day lengths are long and dark periods are short, these crops will stay vegetative. So, many familiar horticultural crops that are short day plants include poinsettias, like I discussed in the intro, as well as chrysanthemums. Even the Christmas cactus wouldn't bloom by Christmas unless we induced flowering earlier than Christmas. So, for most of those listening to the podcast today, cannabis is probably the most familiar example of a short day plant. Okay, so here's the deal. Short day plants, their flowering is signaled when there is a change in the quality of light spectrum that they receive. Specifically, as red light levels decrease and far red light levels increase, that is what seems to trigger the flowering response in short day plants. And if you think about it in nature, what that means is that when the sun starts lowering in the horizon, right, the longer far red wavelengths abound. They are the ones that are penetrating through the horizon, reaching, terrestrial plants. And so once the far red wavelengths exceed the red wavelengths, short day plants produce less phytochrome, which is a protein that inhibits flowering. So during the summer period, phytochrome is produced in abundance and the plants will be vegetative, producing leaves and stems. But as the day lengths shift to shorter lengths of time and there's more far red light, then that phytochrome is produced less and flowering can actually start happening. So, to say it another way, really, short day plants are actually long night plants. Okay, I don't know why we use day as the metric, but really it has to do with the dark period. And like I said at the beginning, short day plants need an uninterrupted period of darkness. If they are exposed to PAR, specifically red light during the dark period, that flowering response will be interrupted. For my cannabis growers, you know that if you interrupt the dark period, right, that your plants will stop flowering. And in fact, they might actually hermaphrodite and start producing seeds instead of flowers. Every short day plant has a critical night length that triggers flowering, and it is different depending on the species of plant. For poinsettias, the night period has to be at least 11 hours and 45 minutes. So basically, 12 hours of night, of dark exposure. For cannabis, we know that a lot of growers, right, they switch from their vegetative stage, which is 18 hours of light and 6 hours of dark. When they move them into the flowering room, right, we see a lot of times that they switch it to 12-12, right? 12 hours on, 12 hours lights off. You might even see that in greenhouses or in light depth tunnels. And that is the convention. But there has been research out of Australia that shows that if cannabis plants have a night period of at least 10 hours, that they will start blooming. They don't actually need 12 hours. So, for those of you growers who are doing 18 hours on and 6 hours of lights off, you could actually switch it potentially to 14 hours of lights on and 10 hours of darkness. Um, and this is why, cannabis plants in nature, they start blooming in the fall rather than their poinsettia counterparts, which actually start blooming in late winter around Christmas out in nature, left to their own accord. Something else that we have learned through research of different short day plants, including cannabis, is that if the critical night length exceeds the threshold, so for poinsettias, if the night period is longer than 11 hours and 45 minutes, and for cannabis, if it's longer than 10 hours, that you can actually induce the plant to flower more quickly. So what that means is that if you're in a greenhouse or you're outdoors and you use light depth for your cannabis crop, at 12 hours, you are going to have a more rapid transitioning from veg to flower than if you did it for 10 hours. And in fact, maybe if you light depth for even longer than 12 hours, you would have even more rapid flowering. So for indoor, what I like to think about is rather than going 12-12, what if you actually had a dark period of 13 hours or 14 hours? Could you actually have faster flowering and potentially more harvest cycles because of that? So what if, instead of having an 8-week flower cycle, what if you could now have a 7-week flower cycle, or anything less than 8 weeks, you could have more turnovers and therefore more annual yields. The other thing that research has shown is that if you allow the temperatures at night or during that dark period to be higher, that some short day plants also flower more quickly. I know that, for vining crops such as tomatoes, right, we have something that we call diff, right, where, we can trigger the flowering and fruiting response by having a higher differential in, say, daytime temperatures and nighttime temperatures. And there has been some, at least anecdotal evidence with cannabis that, we can also steer the crop by having a bigger diff. And so we see a lot of cannabis growers in practice, compensating for, say, they might target 82 degrees when the lights are on, but then want to drop their temperature to maybe less than 70 degrees to have a really strong flowering response. But what this research has shown with short day plants, which tomatoes are not, is that having an elevated nighttime temperature actually helps those flowers produce more quickly. Yes, this research needs to be proven out with cannabis to see, is cannabis as a short day plant more like a poinsettia, or as, a tall crop that, that looks like a tomato plant, is diff more of a factor in the rate of flowering? I would love to see that research. But isn't that interesting, right? Because if if cannabis acts more like a short day plant than a tomato plant when it comes to day and night conditions, at least temperature conditions, there are some real energy savings opportunities. For one, by having longer dark periods or longer night periods, that means that at least during the flowering stage, we need less light energy, right, to maintain a 12-hour photo period. If the photo period is now 8 hours and the dark period is 14 hours, that's 2 hours of lighting energy that you save. Also, by having higher nighttime temperatures means that you need less energy to dehumidify the room. At a higher temperature, at a higher air temperature, the air can hold more water vapor than at lower temperatures, which means that we don't need to remove as much moisture to maintain the same vapor pressure deficit or relative humidity targets. So that's less HVAC energy. And like I mentioned before, if these higher nighttime temperatures and longer dark periods induce faster rates of flowering and flowering development, then we can have more flower room cycles, potentially increasing our annual yields overall. Okay, now one thing we also know about some short day plants is that they may only need to be exposed to long nights for, a certain number of weeks before that flowering cycle is set in. And even then being exposed to long day lengths, they will continue to flower. So that's why with poinsettias, you can go to the grocery store, which is super well illuminated, right? I mean, it's like practically blinding in the grocery stores, especially in the retail area where the poinsettias are sitting because they want you to buy those plants, those flowering plants. The reason that they don't hermaphrodite or switch back to vegetative is because they've been exposed to those long night lengths for a long enough number of weeks that that flowering is set in and they're not going to revert back to vegetative. So, short day plants are pretty cool, right? And there are a lot of beautiful short day plants that we both, like to adorn inside our homes and inside our interior spaces as well as outside. I have a Christmas cactus that's sitting on my front porch right now. And, I keep thinking, well, should I light dep it or should I just let it do its natural thing? And honestly, it's not going to bloom until late December or early January, but it's still really a pretty and cute plant. And for my cannabis growers out there, there are some potential energy and operating savings by playing with the day and night lengths of your crop, whether you're outside, that are, you're going to light up in a hoop house, or if you're in a greenhouse or an indoor grow. I think all of the above, there are some potentials to play with those night lengths and see if you can save on lighting energy, HVAC energy, and maybe even squeeze a little bit more yield out of your operation. All right, well, that is my episode for this week. The beauty of short day plants. I hope you thought it was interesting. If you have any thoughts or comments or feedback, or want to talk to me about any maybe in-house research that you've done with your short day crop, I'd love to hear it. Please contact us at drgreenhouse.com or find us on Instagram, LinkedIn, or Facebook. All right, have a great day, everybody.